Hey guys, it's Miss V. Today we're back covering topic 8.2c, which you will be expected to convert between standard decimal form and scientific notation. So you, the student, will know the difference between standard notation and scientific notation. You will understand that writing a number in scientific notation does not change the value, and you will be able to convert between standard form and scientific notation form with positive exponents today. Okay. So what is scientific notation and why is it important? So if we were to pose the question, what is the weight of the earth in pounds? Okay, and even if you Googled it, okay, you would get some ridiculously large number that looks like this. Okay, now that is a lot of zeros, okay, 25 zeros to be exact. Okay, now the issue is that when we have really large numbers like this, there is room for a lot of human error, meaning we could put it in the calculator wrong, we could miscount the zeros. So just several things that could go wrong here with big, large numbers like this. Plus, if we wanted to multiply this, okay, it'd kind of be really difficult with all these place values. So this is kind of where scientific notation comes into play. So scientific notation is a way to write very large or very small numbers using the power of 10. Okay, so, and again, just a reminder, the power of 10 means like we're using 10 as our base and 2 as our exponents. So for example, 10 squared or 10 to the power of 2 would be 10 times 10 would equal 100. If you notice, the exponent is 2, which is the same number of zeros in our answer. Here, 10 to the power of 4, we have 10 times 10 times 10 times 10, and we get our answer as 10,000. But again, there's a correlation. The number of exponents is 4, and the number of zeros is 4. Okay, so keep that in mind when we're going through these slides. Okay, so there is a certain way to write scientific notation using, obviously we're going to use the power of tens, but our first number here, what we're multiplying by, has to be a number that is greater than or equal to 1, but less than 10. Okay, so again, it can be greater than or equal to 1, but less than 10. Because if we get to 10, that means we're going to this power of 10 here. So it has to be less than 10. And the little square up here is our exponent, and depending on the number, that will change as well. Okay, so here we're going to work through an example. We're going to go step by step and go from standard form to scientific form. So here the number that we're given is 425. And if you read our first step, it says locate the decimal point within the number. But again, here there was no decimal, right? But again, remember that if we put this decimal at the 0, it's always said to be there even though it's not visible. So we can put this decimal here to make it visible. Okay, so it would look like this. And then we still have our times 10, but we're still looking for our exponent. Okay, the next step is to move the decimal to the left until you have a number that is greater than or equal to 1, but less than 10. So here, my decimal was in the first step was at after the 5, and I've moved it 2 times here. So now it's 4 and 25/100ths, which is greater than or equal to 1, but less than 10. So that falls right in between 1 and 10. Okay, and then our third step is to figure out the exponents. You count the number of place values you move to the, sorry, that's a typo, to the left, and that's your exponent. So we moved 2 times to the left, so our exponent is 2. Okay, so we're going to work through a couple of more examples. And just a reminder, these are our steps, and this is the form that it should be in. Step 1, locate the decimal point within the number. Step 2, move the decimal to the left until you have a number that is greater than or equal to 1, but less than 10. And to figure out the number of exponents within by moving the number of place values, sorry. Okay, so example number 1. We want to take 68,000 and we want to write it using scientific notation. So our first step is to locate the decimal. Okay, so here's our number. Step 1, we locate the decimal. It's at the end of this last 0 here. Step 2, we want to take that decimal and move it however many times to the left in order for my number to be greater than or equal to 1 but less than 10. So here I'm going to move it 1, 2, 3, 4, and it places my decimal here. So now I have the number 6 and 8/10, which falls between that 1 and 10 mark is where we're wanting. Step 3, we're going to count the number of spaces that we moved, and that will be our exponent. So we take our decimal 6 and 8/10 and times 10 to the power of 4 because that's how many place values we move to the left. Okay, example number 2. We're going to take a slightly larger number. We're going to take 2,510,000 and we're going to write it in scientific notation. So again, step 1, we always want to locate the decimal first. And again, it's going to be at the very end here. Step 2, we want to take that decimal and we want to move it to the left however many times it's going to take us in order for us to get a number between 1 and 10. Okay, so we're moving it. We end up between here, which gives us the decimal 2 and 51/100, which is, again, it falls between that greater than or equal to 1 but less than 10. Step 3, here comes, now we can write it with the power of 10. So again, we have 2 and 51/100. We moved it 6 spaces, so we have 10 to the power of 6. Again, the number of place values we moved was 6, which is equivalent to our exponent, which is also 6. Okay? But what if we want, so again, why is scientific notation important? Okay, because again, if we took the weight of the Earth, which is this really big number, okay, we could then express it using scientific notation, which would make it a lot easier, and we'd get a pretty number that looks like this. So again, the weight of the Earth using scientific notation would be 1 3/10 times 10 to the power of 25 pounds. Okay, so again, we can take these really, really, really big numbers, okay, and express them in a nice, neat number using scientific notation. Okay. But what if we're given the scientific notation and asked to change it to standard form? So now we're working backwards. We're going to be given the scientific notation, but we want to put it in standard form. Okay, so here again, a couple of steps. We're given our scientific notation over here, which is 9 4/10 times 10 to the power of 5, and we want to get it to standard form. So step 1 says to locate the decimal point within the number. So here we found our decimal point between the 9 and the 4. Okay. Step 2 says to move the decimal to the right. To the right, the number of place values represented in the exponent. Okay, so again, there's 5. Our exponent is 5 to the power of 5. So here we want to move it 1, 2, 3, 4, 5 spaces to the right because our exponent is 5. So we move our place value 5. And step 3 says to fill in zeros and add commas where needed. Okay, so here now we're going to fill in all those zeros, and now we have our, and then we can fill in our commas. So now our number is 940,000. Okay, so again, same basic concept, except for we're just working backwards. Okay, so we'll work through an example. Example number 1 says to write 7 3/10 times 10 to the 6th power in standard notation. So again, we're going to follow these steps listed here. Step 1 says to locate the decimal point. Okay, it's again between the 7 and the 3 here. Again, our number is 7 3/10, and the decimal point is in between the 7 and the 3. Step 2 says to move the decimal to the right, however many places is represented by the exponent. So again, here our exponent is 6, so we need to move it 6 times to the right. Okay, So then our decimal shifts to the end here. And then step 3 says to just fill in those zeros and to add commas. And so 7 3/10 times 10 to the 6th power in standard form is 7,300,000. Okay, so again, hopefully you'll join me at the live AM or PM session to answer any questions that you might have about this video, and make sure you work through those Go Math problems and answer the exit ticket today. All right, I'll see you later.